Let's now begin Module 2, where we will explore some of the key AWS foundational services. We'll examine the Amazon Elastic Compute Cloud Service, Amazon Virtual Private Cloud, and storage services Amazon S3 and Amazon EBS. Let's start by examining the Amazon Elastic Compute Cloud Service, or EC2 as it's known. EC2, as Elastic Compute Cloud, contains two words beginning with the letter C. Amazon EC2 is our virtual machine service for the AWS cloud. Each virtual machine that you create is referred to as an EC2 instance, as it is an instantiation of the EC2 service. You can choose from a large range of EC2 instance sizes and from a number of operating systems, including Amazon Linux, Red Hat, Ubuntu, SUSE, as well as a wide selection of Microsoft Windows Server operating systems. Amazon EC2 instances are virtualized servers running in AWS data centers. EC2 provides you with complete control of your computing resources and reduces the time required to obtain and boot new server instances to minutes. You can programmatically scale your computing capacity as your requirements change. You pay only for the compute capacity that you actually use. EC2 provides the tools for you to build failure-resilient applications and isolate the applications from common failure scenarios. You can leverage the AWS global infrastructure to deploy across regions and availability zones for reliability. When creating or launching an EC2 instance, decide which region you want to have that instance in. Amazon Machine Images, or AMIs, are templates from which new instances are created and come pre-installed with various AWS API tools which enable, for example, scripting of important provisioning tasks from within an Amazon EC2 instance. All Amazon EC2 instances are assigned a private IP address, and you can choose to also have a public IP address assigned to each EC2 instance. Launching EC2 instances from AMIs results in very fast first boot times. An AMI is a template that contains a software configuration such as an operating system, application server, and applications. You use an AMI to launch an instance, which is the copy of the AMI running as a virtual server on a host computer in Amazon's data center. You can launch as many instances as you want from an AMI, and you can also launch instances from as many AMIs as you need. You can create your own AMI by customizing the instance that you launch from a public AMI and then saving the configuration as a custom AMI for your own use. You can also buy, share, and sell AMIs. You select an AMI based on region, operating system, architecture, launch permissions, and storage requirements for the root volume. Multiple instances of different types can be launched from a single AMI. The instance type determines the hardware of the host computer used for your instance and the virtual hardware that is assigned to the instance. Each instance type offers different compute and memory capabilities. Therefore, you should select an instance type based on the amount of memory and compute resource needed for the application or software that you plan to run on the instance. After initial launch, your instance keeps running until you stop or terminate it. Instances are deployed in an Amazon Virtual Private Cloud in an availability zone within a region. We will cover VPCs in more detail shortly. You can deploy EC2 instances to multiple availability zones within a region. You choose which instance types you want and then start, terminate, and monitor as many instances as needed, using either the web service APIs or the variety of management tools provided. Amazon EC2 instances can utilize Amazon Elastic Block Store for persistent block-level storage volumes. These EBS volumes must be placed in the same AZ as the EC2 instance that you wish to attach them to. EBS volumes can be saved using snapshots, and additionally, Amazon S3 storage can be used to store data objects needed by your Amazon EC2 instances. With all of these services shown here, customers pay only for the resources that you actually consume or provision, such as instance hours or data transfer. An Amazon EC2 instance can be in one of the following states. Pending. When you first create or launch an instance, or when you start a stopped instance, it enters the pending state. If the instance already exists and was stopped, it is now moved to a new host computer. The instance type specified at launch determines the hardware of the host computer for your instance. The running state. After the pending state, the instance enters the running state. You can connect to your running instance. When your instance is in the running state, you're billed for each hour or partial hour that you keep the instance running. You are billed for all running instances, even if they are idle and not being connected to. The rebooting state. You can reboot your instance through the Amazon EC2 console, the EC2 CLI, and the Amazon EC2 API. It is recommended that you reboot your EC2 instance instead of running the operating system reboot from the instance. When an instance is rebooted, it remains on the same host computer and maintains its public DNS name, private IP address, and any data on its instance store volumes. Rebooting an instance doesn't start a new instance billing hour. Shutting down. You will stop incurring charges as soon as an instance enters shutting down or terminated states. An EC2 instance in the shutdown state can be started again if required. Terminated. When you no longer require an instance, you can terminate it. A terminated instance remains visible in the management console for a while before it is deleted. You cannot connect to or recover a terminated instance. As with stopped instances, you will not incur charges for terminated instances. Unlike stopped instances, however, an EC2 instance in the terminated state cannot be started again, as terminating an instance deletes that instance from your inventory of EC2 instances. Stopping. Amazon EBS-backed instances can be stopped. When you stop an instance, it enters the stopping state. Stopped. Amazon EBS-backed instances in the stopped state are no longer eligible for hourly usage or data transfer fees. AWS does charge for the provisioned storage space of EBS volumes on stopped instances. You can modify certain attributes of stopped instances, including the instance type. Starting a stopped instance puts it back into the pending state, which moves the instance to a new host machine. When you stop and start an instance, you lose any data on the instance store volumes on the previous host computer. When launching new EC2 instances, the AWS Marketplace provides you with the opportunity to create your new instance with commercial off-the-shelf software that is automatically installed on your instance, offers charging with the pay-as-you-go model, as with Amazon EC2, and centralized billing, as charges are included in your monthly AWS bill. The AWS Marketplace currently offers over 4,000 separate software titles from over 1,100 independent software vendors. Choosing the right EC2 instance type is important. We have a wide variety of EC2 compute instance types for you to select from. These run on Intel Xeon processors, which are compatible with the broadest range of ecosystem software and offer high performance and reliability. Each instance type or family is optimized for different workloads or use cases. Within each type or family, we have multiple sizes, for example, large, extra large, 2XL, etc. When you choose your instance type, you should consider the different attributes of each family, such as number of cores, amount of memory, amount and type of storage, network performance, and Intel processor technologies. AWS recently launched C4 compute-optimized instances which utilize Intel's latest 22nm Haswell microarchitecture. C4 instances use custom Intel Xeon V3 processors designed and built especially for AWS. Through its relationship with Intel, AWS provides its customers with the latest and greatest Intel Xeon processors that help in delivering the highest level of processor performance in Amazon EC2. Intel Xeon processors have several other important technology features that can be leveraged by EC2 instances. Intel AVX is perfect for highly parallel, high-performance computing workloads such as life sciences or financial analysis. Intel AES-NI accelerates encryption-decryption of data and therefore reduces the performance penalty that usually comes with encryption. Intel Turbo Boost technology automatically gives you more computing power when your workloads are not fully utilizing all CPU cores. Think of it as automatic overclocking when you have thermal headroom. Our X1 instance types offer very large amounts of both CPU and memory and are optimized for large-scale enterprise-class in-memory applications. X1 instances are recommended for running in-memory databases such as SAP HANA, big data processing engines like Apache Spark or Presto, and high-performance computing applications. The table in this slide details the associated Intel technologies and storage information for each instance family. Yes, there is a lot of detail in this table. Amazon EC2 lets you choose from several different instance families to meet your computing needs. Each instance provides a predictable amount of dedicated compute capacity and is charged per instance hour consumed. Compute-optimized instances have proportionally more CPU resources than memory and are well suited for compute-intensive applications, whereas memory-optimized instances offer large memory sizes and are well suited for memory-intensive applications. There are also various high storage, GPU-equipped, and very large memory instance types available. EC2 instance metadata is data about your instance and is divided into multiple categories. This metadata can be queried and can be used, for example, to decide how to configure or manage any running EC2 instance. Instance metadata is available from your running instance, thus you do not need to use the Amazon EC2 console or the AWS command line interface to access instance metadata. This can be helpful when you're writing scripts to run from your instance. Note that you are not billed for HTTP requests that are used to retrieve instance metadata or user data. Instance user data is a script that can be specified for an instance, and if so, it will be executed at an instance's first boot. This script can be used to control final specific configuration for your instances that are launched from more generic AMIs. It is important to note that instance user data is executed only at instance launch. If you stop an instance, modify the user data, and start the instance, the new user data is not executed automatically by default. This slide shows an example of user data on Linux. This shell script will install an Apache web server daemon, set it to auto-start for each subsequent boot of the instance, and finally start the service for this boot of the instance. For your Microsoft Windows Server instances, you can send user data via a PowerShell script, as shown in the slide, or with a set of Windows batch commands. This enables you to fully configure your Windows Server instances at first boot, most typically via PowerShell. To determine the user data that was executed when an instance was launched, use the EC2 Management Console, or from within the instance, you can use the URI 169.254.169.254/latest/user-data. AWS provides a number of different payment options for the Amazon EC2 service, and thus you're running EC2 instances. Let's examine these options. On-demand instances are free tier eligible. The AWS free tier is a collection of our services that you can use and learn with for your first 12 months for free. Certain capacity and usage limits do apply. On-demand EC2 pricing has no upfront costs, no long-term contracts, and the most flexibility. You pay by the hour or part thereof for your running instances, and no hourly charges apply for stopped or terminated instances. This is great for applications with short-term, spiky, or unpredictable workloads. Amazon EC2 reserved instance pricing allows you to reserve computing capacity for 1 year or 3-year terms at a significantly discounted hourly rate. Reserved instances providing a billing discount and a capacity reservation that is applied to instances to lower your hourly running costs. A reserved instance is not a specific EC2 instance. It is actually a reservation and pricing contract that can float across various EC2 instances of the same type in the same availability zone and region. If you are expecting consistent, heavy use, reserved instances can provide substantial cost savings over owning your own hardware or running only on-demand instances. Scheduled reserved instances enable you to purchase capacity reservations that occur on a daily, weekly, or monthly basis with a specified duration for a 1-year term. You reserve the capacity in advance so that you know it is available when you need it. You pay for the time the instances are scheduled, even if you do not use them. Scheduled instances are a good choice for workloads that do not run continuously, but do run on a regular schedule and take a finite time to complete. Spot instances enable you to bid on unused Amazon EC2 instance capacity, which can lower your Amazon EC2 costs significantly. The hourly price for a spot instance fluctuates depending on the supply of and the demand for spot instances. Spot instances run whenever your bid exceeds the current market price. Spot instances are a cost-effective choice and ideal for jobs that take a finite time to complete, such as batch processing, encoding and rendering, modeling analysis, and continuous integration. An Amazon EC2 dedicated host is a physical server with EC2 instance capacity fully dedicated to your use. Dedicated instances are physically isolated at the host hardware level from instances that belong to other AWS accounts. Dedicated hosts allow you to use your existing per socket, per core, or per virtual machine software licenses, including Microsoft Windows Server, Microsoft SQL Server, SUSE, and Linux Enterprise Server. Dedicated hosts and dedicated instances can both be used to launch Amazon EC2 instances onto physical servers that are dedicated for your use. There are no performance, security, or physical differences between dedicated instances and instances on dedicated hosts. However, dedicated hosts give you the additional visibility and control over how instances are placed on a physical server. That completes our coverage of Amazon EC2. In this networking section, we'll explore topics covering virtual private clouds, subnets, and network security. With the Amazon Virtual Private Cloud Service, you can define a virtual private network topology that closely resembles a traditional network that you might operate in your own data center. You have complete control over your virtual networking environment, and you can easily customize the network configuration for your virtual private cloud, including selection of IP address range, creation of subnets, configuration of route tables, and network gateways. Each VPC is totally network isolated from all other VPCs. This allows you to build totally separate network environments. For example, a dev and test VPC can be totally separate from a production VPC. VPCs exist within regions. That is, they cannot span across multiple regions. VPCs, however, can span across the availability zones that exist within regions. VPCs are made up of one or more subnets. Subnets exist within AZs, that is, they cannot span across multiple AZs. Just like a VPC, a subnet has a defined private IP address range. The address range for a subnet must be a logical subset of the address range assigned to its parent VPC. Subnets can be private or public. Instances that you place in a private subnet are assigned a private IP address, whereas instances placed in a public subnet have both a private and internet accessible public IP addresses. Public subnets also have a route to an internet gateway, whereas private subnets do not, thus making resources placed within them inaccessible from the internet. Note, though, that all instances within a specific VPC can communicate with each other via their assigned private IP address and a managed routing service that AWS operates for you between the subnets of your VPC. Shown here in the slide are some examples of VPC usage. For example, you can create a public-facing subnet for your web servers that require access to the internet and place your back-end systems, such as databases or application servers, in a private-facing subnet with no internet access. Additionally, you can create a virtual private network, or VPN, connection between your corporate data center and your VPC, which allows you to leverage the AWS cloud as an extension of your corporate data center. You can leverage multiple layers of security, including security groups and network access control lists, to help control access to your resources in each subnet. Security groups act as a firewall for associated instances, controlling both inbound and outbound traffic at the instance level. Network access control lists act as a firewall for associated subnets, controlling both inbound and outbound traffic at the subnet level. Amazon EC2 uses public key cryptography to encrypt and decrypt login information. Public key cryptography uses a public key to encrypt a piece of data, and the recipient uses the private key to decrypt the data. The private and public keys are known as a key pair. To log into your EC2 instance, you must create a key pair, specify the name of the key pair when you launch the instance, and provide the private key when you connect to the instance. Linux instances have no password, and you use a key pair to log in using SSH. Windows instances require a key pair to obtain the administrator password to log in using RDP. Now that we have explored the features of Amazon EC2 and VPC, let's take a look at the EC2 Management Console. Please note that, as is the case with other AWS products and services, Amazon EC2 is also accessible through a command line interface and via the EC2 API for developers. You can see here that I am signed in to the AWS Management Console, which we demonstrated earlier.